The set class. A set is a container that cannot contain identical items. Real life examples of a set include a grocery list. If you understand the purpose of a grocery list, then you understand why it serves no purpose to list the same item more than once. A grocery list is an example of a set. Another example is a student roster, one that is maintained by a teacher or a school district. If you understand the purpose of a student roster, then you understand why it serves no purpose to list the same student more than once. Now, you might have two different students with the same name, but once again, that's not the same thing as listing the same student, the same person, more than once. And another example is the contact list. The contact list in your smartphone. If you understand the purpose of a contact list, then you understand why it serves no purpose to have the same contact listed more than once. A contact list is an example of a set. So, containers we've learned about so far this year include arrays, array lists, linked lists, binary search trees, and several others. For that reason, it's not necessary for us to discuss all of the methods in the set class because many of these methods we've seen before in some shape or form in each of the containers we've discussed so far. So we already know what the purpose of most of the methods in the set class are. The one method we're going to discuss, however, because it's unique to the other classes, is the add method. Now, you may be wondering, well, don't all containers have an add method? That is true, but what separates the add method for the set class from all the other container classes is that, in this case, the set only adds the element to the container if and only if it is not already present in the container. Right? An array list, a linked list, an array, those containers don't mind having duplicate elements, but a set class, by rule, cannot have a duplicate element. So whenever you attempt to add an element to it, before it gets added, the set will check to verify that the element is not already in the container. And only if it is not in the container will it then add that element. Next, we're going to discuss two types of set classes provided by the Java programming language. The first being the tree set class. A tree set is a set container that uses a binary search tree to store its values. Because it uses a binary search tree to store its values, the search, insert, and removal operations are much faster on average than they would be if the elements were simply stored in a linear fashion. And to understand why, simply recall our discussion about the advantages binary search trees have over arrays, array list, linked list, and other linear containers. Because these values are maintained in a binary search tree, TreeSet is able to offer methods like the first method and the last method, the methods that return the first and last elements in the set container by order. Because since the binary search tree keeps the elements ordered to an extent, it's able to locate these specific values relatively fast, faster than you would had you been using just a regular linear container to store it. Lastly, we're going to discuss the hash set. A hash set is a set container that uses a hash table to store its values. All the advantages and disadvantages of a hash table that we discussed earlier this year also apply to a hash set. Just like a hash table, a hash set has the ability to perform extremely fast searches, insertions, and removals under certain circumstances. So, again, under certain circumstances, the hash set can be much faster than even a binary search tree. It can be faster than a tree set. However, that's only when those conditions are met. When those conditions are not met, it can also be extremely slow. So, on average, tree set can be faster, on average. But in the best case scenario, hash set is the fastest option.